So my presentation, so thank you, Zeki, for this opportunity to share my research on quantum technology and ethics of quantum technology. So the title of my contribution is it rational to connect quantum computers? And I would like to talk about a paper I'm writing in collaboration with Peter Vermaas, which is about the rationality of connecting quantum computers. And the rationality, the term rationality has to be interpreted in two ways, strategically and ethically. So the question that are at the heart of this paper are the following. Is it rational to connect quantum computers? Does this connection offer a competitive advantage over other opposing actors? Are there contexts in which it is more ethically beneficial to connect or disconnect quantum computers? In other words, does actors such as states, hospitals, and companies that already have a quantum computer have a significant advantage from connecting this computer to another quantum computer? These questions are particularly relevant because one of the most probable future scenarios is one in which there will not be a single dominant actor, but many actors who will compete with each other in the quantum arena. Therefore, alliances will be strategically relevant. Creating a quantum computer with a large number of qubits is the main challenge, and technologically not an easy one. One option to arrive quickly at a quantum computer with large numbers of qubits is to connect two existing or more existing quantum computers. This option is available to an individual state or company that possesses two or more quantum computers. It is also available to different states and companies when they join forces and connect their largest computer, quantum computers or quantum networks. Now, I would like to explore three scenarios: no connection, governed connection, and blind connection. I will describe these three scenarios and then evaluate them based on 5 criteria that we consider fundamental to understanding the socio-technical scope of the quantum internet and quantum networks. So first of all, no connection. Two actors, A and B, with their own quantum computers, decide not to connect their devices. Each maintains its own quantum computer separate from the other. The decision of A and B for this scenario may depend on different types of reasons: geopolitical choices, commercial objectives, ideological tensions. The blind connection, the blind computing scenario is quite more complicated. Two actors, A and B, owning quantum computers, connect their devices in blind computing mode, in blind connection. Blind computing is a specific quantum application that allows the computers to communicate in such a way that the actors not even will know what algorithms run on the quantum computers they possess. Thanks to sophisticated protocols, the user can remotely access and use the quantum computer without having to reveal what the data they are using and what they intend to compute. And the quantum computers don't register what they are computing, even if they do the job. The decision by A and B for this scenario may be based on common interests, but is actually the more complex scenario because it can be interpreted in many different ways. The government connection, two actors, A and B, with their own quantum computers, decide to connect their devices by agreeing on a series of rules to be respected. This would mean, for instance, setting up a common center to access the connected computers. The two actors can have, again, common interests to connect their quantum computers, but also a need that one actor can monitor what the other one is doing on the connected computer. Now, we propose to evaluate these three scenarios just described using 5 criteria. We decided to use these criteria because we consider them relevant to understanding, as I said before, the social technical nature of the quantum network, the quantum internet, the quantum connection between different kind of devices and computers. So we have quantum advantage. An actor disposes of a quantum computation power that enables practical applications that cannot be run on digital supercomputers. Then collaboration gain. An actor can make use of the quantum computing power gain enabled by connecting the quantum computers of all actors. Equality. An actor has the same quantum computing power as other actors. Then transparency. An actor knows for what applications are run on its quantum computer. And then autonomy. An actor is free to decide what applications it runs. So let's assessing the scenarios according to these 5 criteria. As you can see, we composed this table, but I don't want to delve in this now. I just want to point out that we have 2 important ethical trade-offs: transparency versus autonomy, superiority versus equality. In the first case, both actors can achieve computational gain, but have to make a trade-off transparency between transparency and autonomy about the calculations done on their computer, and they have to decide which kind of autonomy about what calculation they can do on the connected computers. And then the same as for the second trade-off. In this case, there is initially a difference in the size of quantum computers that A and B have, and the actors achieve equality in computational strength, but actor A, for example, has to give up on its superiority over B. Now let's try to analyze some concrete case from this framework. The first case I want to analyze is public and commercial realms. This first case concerns contexts in which responsibility and liability are central values, as in public and commercial realms. Giving up transparency seems then not an option, since an actor cannot know or avoid that its computer is used by the other actor for applications that are illegal or damaging to third parties. In these normative contexts, the scenario with blind computation is ruled out. Trade-off for one has to be made in favor of transparency. So the scenario of governed connection is, however, possible. Limitations on autonomy can be acceptable for the actors as a cost to achieve the computational gain. The second concrete case I want to examine is about developing sustainable technologies. And this case, it's a little bit more complicated. Let's assume that 2 companies that have quantum computers, both with quantum advantage, want to develop more environmentally sustainable technologies. Is it beneficial for them, from an ethical point of view, to connect their devices? Well, the governed connection seems to be the ethically better choice in this case. Indeed, the computational advantage that both actors obtain allows for greater development and collaboration, and therefore greater probabilities of achieving the goal to create and develop more advanced technologies for sustainability. The lack of autonomy could negatively affect innovation and development. However, blind computing appears to be a more controversial choice. In fact, in this case, as given by trade-off 1, the lack of transparency could have serious repercussions, such as an unregulated increase in competition. A counter-argument could be that competition increases innovation, and this, thanks to the effect of the invisible hand, magically allows for more cooperation and is good for the market, and this is good for the market and for the development. The counter critic could be that the invisible hand does not always produce the best social benefits. Selfish motives can ultimately encourage economic actors to do evil by benefiting themselves and harming others. This can also produce negative externalities. Third case, it's about markets and the crime of insider trading. Let's assume that we have a market in which actions take place in a network of quantum computers connected in blind mode. We don't have just two quantum computers, but many quantum computers. Now, we argue that blind connection reduces the risk of crimes such as insider trading or the formation of cartels or oligopolies, and therefore increases collaboration and equity. So it's the preferable, ethically preferable option. In finance, insider trading consists in the misuse of confidential information about securities and stocks. It is committed by anyone who, being in possession of insider information by reason of its position, buys, sells, or engages in other transactions directly or indirectly on its own behalf or on behalf of third parties in financial instruments, such as using such information. Then it's also the crime committed by one who communicates such information to third parties outside the professional relationship or the position held, or if he recommends or she recommends or induces others based on such information to engage in trading in financial instruments. Now, the crime of insider trading arises from information asymmetry. Some actors have more information than others and use it to manipulate trades, prices, etc. Keeping the market darker, thanks to blind connection, may be a way to reduce the risk of manipulation by raising the informational or computational advantage of some actors. It is much harder for A to manipulate the market if it does not know what B and C's moves will be. Let's assume that it knows only the final outcomes of the trades when the market is over. In other words, the moral advantage of blind connection lies in reducing the manipulative effect of information asymmetries. Making a trade-off one in favor of autonomy is therefore the right ethical choice. Therefore, the main conclusion of our paper is that the decision to connect quantum computers is context-dependent and highly complex. Connecting quantum computers is not always and necessarily a rational and/or ethical choice. We have identified two ethical trade-offs that the endeavor of connecting quantum computer faces: transparency versus autonomy, superiority versus equality. Moreover, connecting such powerful computers involves fundamental values for a democracy, for a democratic society, such as trust, health, welfare, voting secrecy, privacy, and freedom of research. Predictably, the use and connection of quantum computers pose enormous questions from strategic and even ethical perspectives. So thank you so much for your attention.
Thanks, Luca. Thanks. And yeah, so I see that there has been some discussions in the chat, and I don't see any questions in those discussions. So if anyone has any particular questions, so one question is, can you please share the link to your paper? It's not published yet, right? So
this paper?
Yeah.
No.
Yeah. So I think we need to say sadly no. You can't. Any other questions? Maybe I can ask one. So if nobody has any questions for you, do you think that? Okay, so there's a question: why quantum is a competition? And maybe I can also connect this to my question. And this is also a little bit self-reflective question. Do you think that as researchers in this field, we are trying too hard to find quantum-specific questions, or are they really that apparent and we're just waiting to be found? Because this question is also asked was today that what is specific about quantum ethics or ethics of quantum technologies, and yeah, so what do you think about it?
Well, thank you for your question. Yes, I think there is this tendency to find a new ethical or social question or new questions about quantum, and I think that I mean sometimes it's we have just to accept that there is nothing special about quantum, in the sense that we have the same problem as in the other technologies. So sometimes the most fruitful way to act is just to reconceptualize some concepts of problems we already had in other technologies and try to understand how they change, they transform in a new context.
Yeah, I definitely agree. And I also think that doing that is still rather useful and rather beneficial in a societal and economic context. So it shouldn't be, oh, this is very specific to quantum, so that only a quantum researcher can do it. But yeah, thanks. So